In today's video, we're partnering with Bill Gates because we were inspired by his new book, How to Avoid a Climate Disaster. You can find out more about how we can all work together to avoid a climate disaster in the link in the description. Hello friends, hope you all are doing well. We are here to explore greenhouse gases and their effect on our atmosphere. Did you know we produce 51 billion tons of greenhouse gases every year in our environment? That means everything is going up into the atmosphere, and those greenhouse gases live for millions of years. We're going to explore these topics and see how we can all work together to eliminate these greenhouse gases and hopefully get our carbon emission down to zero. Here's the basic idea. We have a series of experiments we're going to use to explain how greenhouse gases absorb heat and trap it in our atmosphere. We're going to explore this process in a car, using different environments, flooding one with CO2, and then putting them in balloons to see how these wavelengths are radiated back to the Earth. Being a meteorologist, climate is something that we are constantly talking about and finding new research on. Climate is a study of about 30 years. So whenever we're talking about climate, we're not talking about the now. We're talking about things that happened in the past and are going to happen. And so we use all of this information from ice cores and from fossils and from rocks, and we're able to study our environment. The leading greenhouse gas is CO2, and that's why we have to work together to get out to zero emissions so we can all basically live happily ever after and have trees in our backyard so we can all climb them, so we can have green energy, and so we can all have these wonderful, happy lives that we're not sweating to death in. All right, so we have 3 jars here. One of them is going to be flooded with CO2, one of them is going to have a little bit of CO2, and one of them is going to have air just from the studio in here to demonstrate what's going to happen when we move to cleaner energy. What we should see in this experiment is that when we are flooding an area with CO2 or an atmosphere with CO2, that temperature is going to increase much faster than our normal air is going to when we have more greenhouse gas emissions in our atmosphere. So let's build these, and then I'll put our heat lamps up, and then we'll be good to go, and we'll time lapse it. All right guys, so we have our different environments made. As you can see, this jar over here that is going to be flooded with CO2 has a ton of deforestation, tons of different construction vehicles in there, and cars that are emitting CO2. Now, if we look at our middle one here, we have a little bit of a better situation. We've cut back on carbon dioxide emissions, and we have a little bit of deforestation, but not a lot. Trees are growing, cars are a little smaller and a little bit better for our environment. But if you look over here where we're going to have zero carbon emissions, you can see that we have super green energy and we have cars running on electricity, which is what we're going for because we want zero carbon emissions, hopefully, because that's what's going to help save our environment. So this is our CO2 machine. We usually use the soda stream to carbonate our sodas, but instead today we're going to be flooding our atmosphere over here, and then we're going to turn on these heat lamps, which are going to act as our sun, creating heat down into the environment, which of course is going to heat up our actual atmosphere. But because we have more greenhouse gases, aka the CO2, we're going to see hopefully these 2 containers heat up much quicker than our atmosphere that doesn't have as much CO2 in it. There's that. We're gonna do that a couple times just so we can really make sure we've got some good carbon dioxide in there. And now we're gonna put a little CO2 in this one. So we'll probably put about 2 balloonfuls in there, and then this one is going to receive no CO2. This is just the air from our studio. We're gonna turn these heat lamps on, let them all sit for the same amount of time. They are going to fog up because there is water in our atmosphere, which is also its own greenhouse gas. So we'll see a little bit of water vapor. We're gonna test out the CO2 and see if we can get them to create a little bit more heat than we normally get in our atmosphere. Okay guys, so while these were sitting and baking under these heat lamps, we went and ate lunch, and check it out. We have a temperature of 109.5 over here in our deforest, CO2, unhealthy environment. What's going to happen if we keep doing things that we're doing and not taking care of our earth and reducing our CO2 emissions? Over here, we actually ran out of thermometers, but it's okay. I'm sure it's like right in between. But if we look at our clean oxygen and our clean air, it's at 100. So that means that there is a 9 degrees temperature change between adding a ton of CO2 to our environment than if we don't have any CO2 at all. So let's talk about these greenhouse gases and why they do what they do and why they trap in this heat. So the sun brings heat down to our earth. Our earth, of course, in turn absorbs that heat and takes it all in. But our earth can't absorb all of it. Some of it has to be emitted back up out into space. So as these heat is coming down, it's getting trapped, and there's some being emitted back up into the atmosphere, what's happening is these greenhouse gases are trapping this heat. So our atmosphere here is getting 100 times hotter, well, 10 times hotter than it is over here with our normal air, where everything is able to go down, be absorbed, and emit back up into our atmosphere. Because we have the trees, we have the clean energy, because we have this energy being emitted down to our atmosphere, we have to have something that in turn absorbs it and releases it efficiently back up. So we don't want this to happen, so we have to stop our deforestation. We have to reduce our greenhouse gas emissions so that we can move towards this clean, green, and healthy energy. All right guys, so before we head inside and do our other series of experiments, I had to show us a real world example of when we feel heat. And that's with our cars. We all know that example on a spring day or even in the winter when it's super cold outside, but you get in your car and it's nice and toasty after it's been sitting in the sun. That's exactly what's happening in our atmosphere. The greenhouse gases and heat is getting trapped because of those excess, and it's causing it to heat up and warm. So the glass is acting as a barrier. Nate and Callie have tested this out before, where they place a thermometer inside the car and outside of the car. That's a perfect example of what's happening here in our atmosphere. So let's head inside and check out a couple other different environments and different examples of what happens when we add greenhouse gases to our environment. All right, let's move into our last experiment. This one is so cool. So we just talked about how greenhouse gases are in the atmosphere, and there's naturally greenhouse gases in our atmosphere at all times. Without them, our Earth would actually be incredibly cold. It would be negative 18 degrees Celsius. So it's a good thing we have our atmosphere and we have those greenhouse gases, but in excess of them causes a little bit of a problem, and we're going to explore that now. So right here I have an air compressor and I have our CO2 producer again, and we are going to put the air into a balloon. So I'm going to fill this balloon with CO2, and we're going to do that. And as you can see, this balloon is really cool. I'm gonna let some of the CO2 out. This balloon is pure CO2, and I'm gonna go ahead and write that on the outside. But as it was pressurized into here, or depressurized and expanded, you can see that it's cold. It has some condensation appearing on the outside. So we're gonna allow this to acclimate to room temperature. I'm gonna go ahead and write CO2 on here. So our CO2 balloon is just gonna hang out there. For our other balloon, we're going to add air, but we're not going to breathe into this balloon and blow it up like we normally would, because then we'd be putting CO2 into the balloon because our bodies want to breathe out CO2. So we'd just be adding CO2 to the balloon. So we're going to use our air compressor pump this up, and then we're going to check out the infrared camera and talk about how these molecules move and how they block light from traveling through the greenhouse gases. All right, so we have our CO2 and we have our air balloons ready to go for this experiment. So with greenhouse gases, what they do is they trap the heat that's being traveled from the sun. So if we have sunlight coming through our atmosphere and it hits me, which I'm gonna act as the Earth, as our heat source, when that heat bounces back, it should be able to radiate back to space. But instead, what's happening with these greenhouse gases is they're trapping in that heat and energy because a wavelength of heat and energy is traveling at a specific rate, and it's hitting these, trapping that energy and bouncing it back to Earth, which isn't good and causing our Earth to heat up. Now, With our normal air balloon, what's happening is this one does not have excess of CO2. What's happening is heat is able to travel through it and it radiates just a little bit back at Earth, but it allows a lot of it to escape back out into space, which allows our Earth to stay at a super reasonable temperature that allows life to be sustainable and to live. So let's check it out on our flare camera and we'll see how our heat is impacting and if this is actually true. So here's the CO2 balloon and here's the air balloon. In the air balloon, you can see me through it still. Now, when we move the CO2 balloon in front, it's a little bit of a different story. Remember how we talked about those wavelengths traveling and hitting this greenhouse gas and bouncing back? That's what's happening. Now, I'm setting up our heat lamp now to act as the sun because this is how we really want to test this heat traveling through. So we're gonna go ahead and turn on this light and have some radiation pass through this balloon into our IR camera to see the wavelength that's traveling through. So this is our CO2 balloon, and then this is our air balloon. Well, this is me normally, and this is our air balloon. So we all learned in chemistry class and physics that when molecules vibrate at a faster rate and a faster pace, they heat up. That same concept is what's happening with our greenhouse gases in the atmosphere. So when we turn this light on, all of these molecules are vibrating faster and getting excited. That happens in our air and in our atmosphere also. So when I take this air and set it in front of this light, we're going to see that yes, some of it is passing through. And if we look at our IR cam, you can see that the right wavelength is passing through. So all of this energy is escaping back out into Earth. That has to happen because if it wasn't happening, our Earth would be unbelievably hot, which is what happens when we have an excess of CO2 and other greenhouse gases. As you can see, looking at it, it looks perfectly fine. But if we look at our IR image, you're going to see a completely different story. A lot of heat is getting trapped because it's the right wavelength and bounced back towards our source. So because these greenhouse gases are absorbing at just the right wavelength and bouncing our energy back towards Earth, that's what's causing the heat up of our atmosphere. You guys, we're always doing fun and different things here, and if you want to know more about greenhouse gases, let us know in the comments below because I would love to explore these topics. And if you want to learn how to avoid a climate disaster, make sure you check out Bill Gates' new book. It has full of all kinds of awesome information. We have to get our carbon footprint down to zero, and this book has the perfect plan laid out. We'll see you in the next one. Talk to you then.